TypeScript has a unique way to compare if two types are compatible. In fact, this is completely different from any other programming language you have worked in the past. Today I will talk about the structural type system of TypeScript. Understanding this system will help you understand the language itself. It's the glue that connects every single feature of the language. This episode is a journey to the TypeScript's type universe. I will show you practical examples to understand the concept, and we will answer the question why structural typing is so useful and why the creators of the language decided to implement it like this. Stay until the end because we will be navigating between the different types using the most advanced tool ever created for teaching purposes. A whiteboard. Okay, that was not that impressive, but still, it's a pleasure having you here, so let's get it started. Hello friends, it's Nikos here and welcome back to the channel. If you are new here, this is a series about TypeScript. Every week we are exploring a different feature of the language with practical examples, real-life scenarios, and we try to get the most out of it while having fun. Today we will be talking about types. I mean, what else, right? So TypeScript is completely different when it comes to comparing types, as we've seen in the beginning of this video. Basically, it starts with this simple idea, the simple concept of structural type system. Let's take two object structures, for example. To tell if they are compatible, their types, the language will not check the origins of their types, for example, the classes or their interfaces. It will actually compare their members. And if these two types have the exact same members with the exact same types, then these two types will be compatible. To summarize this, if we have an object structure in TypeScript, then the type of the object structure will be compatible if the two types have the same members with the exact types. Well, this is a very theoretical thing. We need to observe this behavior in practice and then you will understand it better. So here we have two classes, a dog and a cat. We all used to the idea that an object is created from a class, and that's also true in TypeScript. So here, for example, we can define a cat, which is a cat, and assign a new cat. We can do the same with a dog. And now, in any other language, there is no way that you can assign the cat to the dog, because the origin of the cat object is the cat class, and these two classes are completely different classes. They don't derive from the same abstract class animal, for example. They are completely independent. And yet, check this out. If I try to create an object animal, which let's say is a dog, I can, of course, assign a cat in it. And this will work perfectly fine in TypeScript without throwing any errors. Of course, I can have the same if this was a cat and I try to assign a dog. And we don't get any errors whatsoever. And now you will ask me how this is even possible. If you get used to languages like C#, for example, or Java, then probably this doesn't make any sense. So it turns out that this structural type system is all about comparing if these two types are similar. So, for example, since our dog here has the name property, which is a string, and the cat has the name property, which is a string, then we say that these two types are basically compatible. So they are interchangeable. Basically, this works similar to interfaces and how they work in different languages. That's why interfaces are so powerful in TypeScript, because why bother in creating classes and setting their constructors and repeating yourself again and again, right? You have much less control if you use an interface. We talked about this in a previous episode because we've seen that a class has some extra keywords you can use, but more or less you can do your work much faster and simpler. By the way, I have made a great comparison between the different types that we have in TypeScript, like aliases, classes, interfaces. I will put the link in the description of the video. You should definitely check it out. Now let's introduce an interface called Animal. Obviously, if I change this to an animal, this will also work, because all these three object structures have the exact same properties. Let's add a new method to the dog class. Let's say that the dog can bark, for example. As you can see, we still don't have any issues here, because our animal has a name and the dog has some extra properties. But for this contract, for this interface animal, we are more than fine, because the name exists in both the structures. But guess what will happen if I say, for example, that this is a dog and assign a cat? Yeah, I don't think this will work, because now a dog is expecting the bark method, and our cat doesn't have any. So if you try to assign a cat, or if you have, let's say, a general animal, and let me give it a name, then we will get the same error here, because neither the animal or the cat class have the bark method. So this makes them incompatible with the dog. But the absolute opposite will work. So if you try to assign this to a cat, it will work perfectly fine. Or if you try to assign a dog to a cat, it will also work. I hope this gives you an overview of how structural type works in TypeScript. It's completely different from the nominal type system that we have in other languages like C# or Java. In these languages we are checking the origin of their types. And now a small reminder, if you really want to check the parent, the origin of a specific type, and this type of course is an object structure, then what you can basically do is use the instance of operator. So if you say, for example, dog is an instance of a cat, then this will definitely be falsy. However, this will not change anything, because these two types will still be compatible if they share some common members. Teacher, I have a question. Why TypeScript is that strange? So the reason this feature exists is to make the language backwards compatible. And you know, JavaScript is a dynamic language, right? And it never had strict types. So existing JavaScript code will work as is in TypeScript without any refactoring. And that's why structural typing is so important. Without structural typing, the whole world, the whole universe of JavaScript will collapse. That's how TypeScript won the race of strict typing languages. There were plenty of implementations out there that were compiling to plain JavaScript, but nobody wants to write everything from scratch. Nobody wants to learn a new language, to learn a new syntax, to rewrite their applications. Such a shame, but it's a reality. TypeScript is adding only a minimum set of rules to enforce strict type checks in your code by preserving the mechanics of the JavaScript language. This not only makes it backwards compatible, but it also requires less effort from your side to integrate it in your projects. Now let's analyze what is happening in the previous example, and to do that we will try to draw the types and how they are related. So this circle here represents a cat, and it is basically the type of the cat, which is a class. So similar to the type cat, we have the type animal, which is basically the exact same structure, right? It has a name and the name is a string. So how these two are related with the dog type? So the dog class has everything the cat and the animal has, but it also contains a bark method. So the dog class is like a superset of cat and animal, and this is what we will draw here. So this will help you understand that you can assign a cat and an animal to the dog, but you cannot actually assign the opposite, right? Okay, these examples here are pretty simplified, and it doesn't cover all the use cases that we have for sure, but all I'm trying to represent is what types are compatible with the dog class. So now let's take it a bit further. You know, dog is not the high-level type we can use in TypeScript to describe an object, because we have the object type, and the object is actually the parent, the top type of all object structures. So we can basically place the object circle here as a top type. Can you think of any other higher level type of TypeScript? Any other type? Any? Okay, yes, it's any. So this is the parent of all types in TypeScript. So now you have it. Let's recap what we have here. You can assign a cat and an animal to a dog, and you can assign all of this to an object, and you can also assign all of this to any type. The structural type system doesn't only affect object structures, but any kinds of types as well. There are plenty of types that encapsulate others, like for example an object, or there are unions that combine different types together. We have generic types, we have literal types, and the list goes on. Let's zoom out. This is a cat object. Let's see what else we have outside. Let's leave the house, leave the city, leave the earth itself. What are the top level types that we have in TypeScript? Let's try to draw them here. So here's a recap of what types are available in TypeScript. These are the top level types you can have in TypeScript. So we start with string, we also have booleans, we have numbers, we also have objects, of course, and there are symbols. This is a new JavaScript feature, but obviously it's supported in TypeScript as well. Let's draw their circles. And as you can see, all these circles are completely independent, so none of these types are, let's say, compatible. On top of this, we have some special wildcard types. So these are the parent of all types of TypeScript. So one of them is called any, as we've seen, and this basically means that you instruct TypeScript that, you know what, TypeScript, I know what I'm doing, so don't bother me here. I give my permission to just disable the type system. Most of the cases you simply don't know what you're doing, and this causes a lot of issues, so that's why sometimes it's better to use the unknown keyword, which is again the parent of all types, and it again works like any. So basically you instruct TypeScript again that you don't know what this type can be, but you want to protect yourself from unnecessary mistake. So if TypeScript sees some issue on how you use these variables, it will try to protect you. And we also have another wildcard, which is called never. And this is actually the opposite of any of these types that you see here. It's basically like a black hole. It means no type must be assigned to that thing no matter what. Think of it as the value null, but for types. It is useless as a value, but it plays a big role in the logic of your application. Now let's zoom in a bit and let's try to see which values are acceptable in any of these types here. So let's start with the boolean, and obviously the acceptable values here will be true or false. Then we have string, and this basically accepts any value that starts with double or single quotes. And also the empty string is also an acceptable string, right? Then we have object, and this basically stores all the reference values, the values that are mutable. And this basically means any kind of object. It also supports arrays, because arrays in JavaScript are objects, and of course dates or any kind of object that is defined in the API. And remember that null is also an object in JavaScript. So yes, null is an acceptable value of an object. Then we can move on to number, and here this is another weird example of type. It basically accepts any kind of a number. We can have, for example, integers, we can have negative numbers, we can have floating points, we can have 0, which is an acceptable number as well, and we also have not a number, which is a number, as I will keep saying in my videos. So these are the main types. Of course, on top of those we have any and unknown. Oh wait, I forgot another one, which is the symbol. And yeah, let's add this here. And yeah, basically that's all you need to know about the top level types of TypeScript and their acceptable values. We've seen the top level types of TypeScript, and you will be probably wondering how come undefined is not one of them. In JavaScript, we have the following nullable primitive values. Null, which is something that we've seen before, it's a part of, basically it's an object, and undefined. This is a value that a variable gets when no value is assigned to it. So don't be confused here. Nullable values are not actual types in TypeScript, but values that can be assigned to variables. And yes, I hear you, this sounds Greek to you, so let me explain. Let's say that we have a variable always undefined, which has the type undefined, and obviously I can only assign undefined. And we can also have the always null variable, which is null, and we can actually assign null in it. So guess what will happen if I try to assign undefined to a null? Yeah, spoiler alert, it will not work, because undefined is not assignable to a type null. So this kind of feels that we are using the type undefined and null here to assign to these two variables. But I don't think these two are actual types, but values. We've seen already that we have literal value types in TypeScript, and to give you an example, we can have, for example, the variable alpha, which can accept the different forms of the alpha letter, and here we can only assign these two values. So these two are the acceptable values this variable can have. And this works pretty similar if I go here and add, for example, the null, and TypeScript will actually allow me to store the null value. So don't get confused, these two here are values, not types. You can use them to create your own types. I can create, for example, this type alpha and assign this union here. Now I can use it to create variables. One last thing I want to show you is if you have, for example, a space object here and you try to assign a null, TypeScript will throw an error, and that's a little bit strange, because we said before that null is actually an object, but here we get a message that it's not assignable to an object. That's for a good reason. If I open my TypeScript configuration file, you will see that by default the strict flag, the strict type checking is set to true. So if I go ahead and set this to false, then you will notice that TypeScript will stop complaining. And that's because when this strict flag here is true, then all these flags are true. And as you can see, one of them is strict null checks, which when type checking take into account null and undefined. This basically means that null and undefined are not available types you can assign to an object. And as I said, this is for the best, and this is the default behavior. If you want, of course, in your project, you can disable this flag. Of course, I would strongly recommend you will not. This was a short introduction on how to think about types when it comes to TypeScript. Let me know if you have any questions, and make sure you subscribe, because we will be covering more on this topic in the following videos. I will try to help you understand how all the different features of the language come together. In my blog post about structural type system, you can find everything I presented to you in this video, including the coding examples. It's a nice way to review what we've learned and to keep it as a reference. If you like this video, then you will love the Too Long to Read TypeScript series. And I've made a playlist for you just to make it easier to find all the episodes. I will put it in the description of this video. Let me know what other TypeScript topics or any other topics you want me to cover in the next videos. Thank you very much for watching this video and for supporting my channel. I hope you enjoyed this episode. I wish you to have a nice creative day, and I will see you in the next one.